My board is right here. Go over here, and there I am. All right, let me know when you can see my whiteboard.
It's visible to the blind man.
Oh, Lord. Okay, so we're gonna start with one question. The question we are going to subnet is what we are going to use to build our topology. So right here, I'm going to start with, let me say, I'm going to subnet based on the number of hosts. So let's say given 10.10.10.0/24, create a network or networks, create networks. Yeah, I don't want to delete this. Create networks with with 10 hosts. Let's keep it simple. With 10 hosts. So this is the question. And if we write down the subnet mask for this guy, that will be 255.255.1234567 I want to believe we all agree to this extent. So now somebody tell me, what is the first step we have to do? This is going to be more interactive than just me talking. So what is the next thing we need to do?
We convert the 10 to a binary.
Convert 10 to binary. Somebody give me that value. Convert 10 to binary. Somebody give me that value, please. Give me the value. If I convert 10 to binary, what will I have?
That'll be 0, 0. Huh? Sorry, that'll be 1 0 1 0.
Yeah. So if I convert 10 to binary, I have 1010, which means 4 bits. So that means we need to collect, or we need to reserve 4 bits from this available host, so that we'll make sure that no matter how many number of networks we are going to create, is going to have at least 10 hosts in them. And because we are saving the hosts, we are going to collect the bits from the left side, which is the side closest to the host. So let me put their positions in the binary table. This is 1, 2, 4, 8, 16, 32, 64, and 128. So if I collect 4 hosts, starting from the side closest to the host side. So I'm turning off this 1, 2, 3, 4. So whatever I do, I need to make sure that these 4 host bits. Please mute. Please mute. I need to make sure that these 4 bits are turned off. Whatever is left, I can turn them on. So I'm going to turn on this for 1, 2, 3, 4. All right. Now we know we've collected 4 bits. Now somebody tell me, what will be the new subnet mask for the networks that we are going to create? What will be the new subnet mask? Right now, we don't know how many networks we are going to create, but let's talk about the new subnet mask for the networks we are going to create. Somebody give me that value, please.
Okay.
Please, if you're not talking to me, mute. What will be the new subnet mask for the networks that we are going to create? I have all day. People who want us to sit down here all day. Today is Sunday. I don't have it. I'm not working today. The new subnet mask for the networks we are going to create.
255.255.255.240.
255.255.255.240. I
Yeah.
don't know how we got this. Please let me know. You don't know how we got this value. Let me know.
It's a little bit confused. Like, I didn't get it.
Okay. So we started with this subnet mask 255.255.255.0. That's what we started with. Now we want to find the new subnet mask for the networks that we are going to create. Right now, we do not know how many networks we are going to create, but based on the number of bits that we have turned on from this subnet mask, it is obvious that we are not going to be working with this default subnet mask anymore. So we need to find the new subnet mask. In the default subnet mask is just 255.255.255.0. That was because this entire 3 octets are all turned on. So all this one we are 1111111 1111111 11111. These guys were turned off. But now we've collected 4 bits from here to add to this side of the network. So the new subnet mask is going to change. Felix, you understand that how 255 came about, right?
Yeah, yeah.
So your
They're
problem
on. They
is
are
240.
occupied. Yeah.
240 is the bits that we collected. We sum up their positions in the binary table. We collected 4 bits. So the position of this bit is 128. Position of this one is 64. Position of this one is 32. And position of this one is 16. So when you add all these values together, it gives you 240.
So why did we take two? Why did we take 4 bytes?
Because
4 bits or
we
some.
need to save. The question says create networks with at least 10 hosts in them, and for us to create networks that have at least 10 hosts, we converted the 10 to binary and we have 4 bits. So we need to make sure that there are 4 bits available for the host before we can collect whatever is left. So we make sure that these 4 bits right here, which is these 4 bits we got here, that's the 4 bits we left untouched. So once we save these 4 bits, whatever is left, we now turn it on. So what is left was these 4 bits, so we enabled it 1111. That's how we turn it on. So when we get this 4 does not apply to this. This 4 right here applies to this. It's coincidence that we have 4 this way, we have 4 this way, because of the nature of the question. If we had 5 here, that means we are going to be saving 5 bits and we'll be having 3 left. So when you are finding the new subnet mask, you're going to add the bits that you enabled, their position on the binary table. You're going to add them up for you to get your value on the last octet. That's why we did 4. Does that make sense?
Yes, but that makes sense for me. The first step that the first question you said create a network with 10 hosts, 10 hosts, right? But
Mm-hmm.
the first step that you gave, I mean that you are enumerating, is saying that we should um convert 10 into bits. Like, um it's a little bit confusing for me.
Felix, have you been here since Friday?
Yeah, yeah, yeah.
It's weird you're asking that question.
It's like I'm a little bit backwards.
That's why I'm asking, have you been here since Friday? Because we talked
Yeah,
about this
yeah.
on Friday. We talked about it
Mm-hmm.
yesterday. That's why I didn't go ahead to discuss, because I want to believe we have all gotten past this level.
Yeah,
So where are you lost?
it's when you are converting where are we pulling the 10 from?
The 10 is in the question.
Yeah,
It's just the
10
question that we
hosts.
were given. If this question was 20, then we're going to be converting 20 to binary.
Okay. Okay.
So whatever if we are creating, if the question said we need to create 10 networks, or we need to create 6 networks, whatever is in the question is what you're going to convert to binary, because that is how you know how many bits you need for you to work with.
Mm-hmm. Okay. Okay.
Did I clear things up?
Yeah, yeah.
Still confused anyway?
Can you help me converting the 20 in the bits? Let me see.
It's normal binary. Convert 20 to binary. If I converting 20 to binary, I'm going to have 10100. This is 20 in binary. It's the normal binary we do. You want me to do the conversion so you see?
Yeah.
That's okay. Normal conversion of convert 20 to binary. Convert 2 to, I know this is how we were taught in primary school. So if I convert this to binary, 2 into 20, or 20 into 2, however that goes, is what? If 2 divides 20 will give me what? Felix,
Probably
I'm
10.
asking you. What is
It's
the
giving 10.
remainder? What is the remainder here? Is there any remainder when 2 divides 20?
0.
I'm now asking you, mute yourself.
If you divide it into 10 into 2, it's 10. When divided into 2, it's 10.
Is there any remainder when 2 divides 20?
No, there's nothing remaining.
So we write 0. And then we do again. If 2 into 10 is what?
5.
What is the remainder?
0.
0. 2,
Yeah.
2 into 4 into 5 is what?
2 into 5.
Uh-huh.
2.
What is remainder?
Can be 1.
1. 2 into 2 is what?
0.
2 divides 2.
Oh, 1. Yeah.
What is the remainder?
It's gonna be 0.
2 into 1. In binary is
Uh,
not possible.
yeah.
So it's 0, then you bring out this one. Is 2, is 0 remainder 1 right here. So you collect the remainders from bottom to top. You collect the remainder from bottom to top. So if I collect the remainders, is 10100. Same thing I had here. So that is the same process we did to convert 10 to binary. It's just that many people have, it's normal binary that you can do in your head in 2 minutes.
Okay.
Does that clear things up?
Yeah. Yeah. Yeah.
Whereas
Now,
whereas you want to catch me, tell me.
no, that's the only place. That's the only place that the thing got me confused, but it's more clear now.
Okay.
Yeah.
Any other question? Question, guys, before we continue. Okay, so we found the new subnet mask. So no matter how many networks we end up creating, the subnet mask for all the networks is going to be 255.255.255.240. Or what? If I'm going to write this in the SADA notation, this would be slash what?
It's going to be /28.
Slash 28. I don't understand how we got 28. Please let me know. You don't understand how we got 28. Let me know. So that means everybody understand how we came about 28. Now let's talk
No,
about
no, please explain this. Maybe
Solomon.
just throw smaller than that 28. Just
The
let's check
28
it.
is the number of bits that are turned on. We already know that we started with /24. So 24 were turned on. How many more did we turn on in the process of breaking this network, Solomon?
4.
So 4, when you add 4 to the one we started with, what will it give you?
28.
Does that clear things up?
Yes, ma'am.
Thank you. All right. So let's continue. The next step is for us to find how many networks we're going to create. So knowing what we have right now, how many networks are we going to create? Somebody give me that value.
That's 4. That would be 2 raised to the power of 4.
Justify your answer, please.
Okay, since we have 4 numbers of bits, so it will be, since the formula is 2 raised to the power n, and n is the number of bits that is turned on, so it will be 2 raised to the power 4.
Okay, and what's the right value? That should be around 16, right?
Yes.
So we are going to end up creating 16 networks. I don't understand how we got 16. Please ask your question. Okay, so let's proceed to number of hosts. We agree we are going to be creating 16 networks. Now, in each of these networks, what will be the number of valid IP addresses in this? So number of hosts, when you hear host, it means number of valid IP address. We have 2 raised to power h minus 2. This will give me what, please? Give me the values. What is my h?
H is going to be 4. The turn off bit, yes.
So this will give me, I believe, 14. If I do the math, this is 2 raised to power 4, which is 16. 16 minus 2 is 14. So each network we are going to create is going to have 14 hosts. When you hear hosts, it means valid IP addresses. So we are going to have 14 valid IP addresses in each of the network we are going to create. Ask your questions.
Ma, please, I will take you back a little bit, Joe. I'm trying to
Okay.
figure out that 16 on my own, but it's not, I'm not getting it.
This is 2 raised to power n, where the value of n is the number of bits that are turned on. And how many bits did we turn on here?
4.
That's where we come about the 4. If you do the math, 2 raised to power 4 is 16. Does that refresh things?
Yes, ma'am.
Okay. Any other question? All right, so let's go to the last thing we need to find. Somebody give me our increments. What was going to be our increment?
240.
Eh? I did not hear that in right, did I? Somebody give me my increment.
You were saying yesterday,
16.
if we want to get the increment, we use 250. Is it 5 or 6 minus something
Increment
like?
to be 16.
Me said.
Increase is
I
16
think we use 256 minus
minus 240.
the
240.
subnet mask, the ending of it, like 240.
Why that will work in this scenario, it doesn't work in all scenarios. But if you still understand how we've been taking our increment from the last Fridays, Saturdays, and now here, tell me how do we find our increment? I don't want to go with the plan of doing 256 minus 240, which of course will give me 16. But this does not apply in all cases. But the way I have been doing it since Friday will apply in all cases. So that's why I want you to give me from what I've been saying.
Okay, I think increment is actually going to be the last piece that we turn on, which is 16.
So their position on the binary
The
table,
position,
not
yes,
just the
yes.
last bit we turned on, because if you say we turn it on, it's just one. But we are picking their position in the binary table, which in this case is 16. So our increment is the last bit that we turned on, its position in the binary table. That is our increment on that octet. So this guy, we are going to be incrementing by 16 on the last octet. If we were borrowing this on the third octet, that means we need to be increasing on the third octet. If your borrowing ended in the second octet, you're gonna be increasing on the second octet. But here, our borrowing ended in the final octet, so we are going to be incrementing the final octet by 16. So now we have all that we need to start listing our network. Of course, I'm not going to be listing 16 networks. I'm just going to list like 5 or 6 of them and the last one. So let's go ahead and list the network. Somebody give me the first network that we will have here. Solomon, give me the first network that we are going to have here.
Okay. We have 10.10.10.0.
Give me the next one.
We have 10.10 dot 10.16.
Give me the next one.
We have 10.10.10.32.
T1, give me the next one.
Thank God. I escape.
It's gonna be 10.10. Wait. I need to do math calculation. 48.
Give me the next one.
Me?
Yes, you.
Oh my gosh. Okay, 64.
64. Okay. Let me see who else I'm going to pick on here. Felix, give me the next one.
I think we should do 64 plus 16
Give me the
together.
network that I'm supposed to be creating. You
Yeah.
start saying it and I'll be writing.
That's gonna be 10.10.10.80.
Hmm? Instead of
Yeah,
what? I didn't hear you well.
.80.
Dot 80. What will be the next one?
Um, let me calculate this. It's gonna be 96. 96.
Dot 96. So how many have 1, 2, 3, 4, 5, 6, 7? So this will go on until the last network. Felix, give me what will be the last network we are going to create here? We are going to get.
Wow.
Okay.
Okay. So we are creating 10. It's gonna be 160.
That's wrong. What will be the last network that we will create here?
So 1, 2, 3.
10 dot. Okay, I'm not the one. Oh, sorry.
10.10. Okay, sorry.
Can get it.
I think 10.10.10.110.
No, I'm talking about the last network. And even if that is the next network, cannot be 110. In fact, we are not going to have a network that starts with 110 because that number is
10
not a
dot 10
column.
dot 10.240.
.240.
10.10.10.240. That will be the last network we will have here.
.240. Yes.
So all the 16 network we're going to create, this will be the last one.
Yeah.
So let's get we're going to be using 4 networks from here in our topology. So let's get the Solomon, give me the range of this network. This network is going to range from what?
Ma,
Isemuma?
is
Sir
it? I
Isemuma?
didn't hear you.
Give me the range of this network. What will be the range?
Happy Father's Day, sir.
Ma, I can't tell from you. Just one example I remember.
T1, help him out. Give me the range of this network.
Okay.
You mean like the next one?
This
It
one,
used
the
up.
first network, we're trying to get the range of the network. Give me the range.
Oh, it's gonna be 10.10.10.1.
Dot 15.
Oh,
Wait, yeah. Wait, where?
Ma,
Yeah, it's
please.
gonna be
Hello, Ma.
15.
Can you hear me?
Yeah.
Okay, yes. Okay.
You don't understand how we got 15, T1.
No, I get it now. I get it.
Okay,
It's
so since you get it, give me this one. What
Why
will be
then?
the range of this one?
10.10.10 dot
31.
6. Yeah, that's right. That's right.
T1, give me this one.
31.
10.10.10.47.
Give me the next one.
10.10.10.63.
Next,
10.10.10.79.
next.
10.10.10.95.
Continue.
10.10 dot 239.
Huh?
I don't know.
Work it out.
It's gonna be 111.
6 plus 16.
-1.
Wait.
That's 111.
Yeah, 111.
Yeah.
You want to give me what would be the network range of this last one?
10.10. That 10.239.
Oh,
No, sorry. My bad. 255. Sorry.
255. 255. Please ask your questions.
Subnetting is very.
It's very sweet, I know. You're
When you do
welcome.
it today, tomorrow, you just forget it.
It's not only subnetting, it applies to everything in life. When you learn something and you don't continue working with it, you will obviously forget. So it's not just
No,
subnetting.
it's a kind of just little mathematics that involves some
It's
dots.
basic math. It's
Which if you
basic
miss,
math. Primary 2 mathematics.
no good
Yeah,
deal.
the step, like there's too many steps in it. That's the problem. Like the steps are too many. Yeah, but
It's because I am listing all of them for you to understand. I could do this with just 2 steps, but trust me, you are going to be so lost.
I
have a question.
Go ahead.
So is this like something that would be on an exam, the way that we're doing this?
If you're writing a CCNA exam, you're going to need to know how to do subnetting because there will not be a calculator for you.
Okay, thank you.
Mm-hmm.
Excuse me, I have a question.
Go ahead.
Yeah, since we're based on what we are going, is this like this is going toward security, I mean network plus or CCNA?
This is a basic networking. This does not, if you want to cover CCNA curriculum, it's not something you cover in 2 months. This is basic networking. So subnetting is part of a CCNA topic. So you're not
Okay.
preparing for any exam in this class.
Oh, okay, I see what you mean. All right.
Questions, please. Solomon, you say what?
Jesus. No, sorry.
Questions.
All right, again, so after this class, do you guys have another class, above this, or just we offer these 2 classes right now?
I don't understand.
I mean, after these 2 classes, like this cybersecurity ones and networks, do you guys have a next step for it, or just what you guys cover right now?
Did you start this program with us?
I did.
Did you attend the onboarding session?
I think the first class I did not. Right. Sorry. Don't believe this one. I think the first one I'm not.
Because that question is very weird if you had started this session with us. But it's not a question I can answer here. Feel free to drop me a message on Discord. I'll respond to that.
All right. Thank you so much.
Mm-hmm.
Can you hear me, ma?
I can hear you.
Ma, please, can you give us one example of the kind of questions that you might likely see probably whenever I want to do any exams, probably any networking exams, that doesn't require bulk calculation like this, that we can easily get the number. Like for instance, the questions you've been giving us, the example you've been giving us, you said create a network with. Obviously, when we start the exams, if probably it's an OBJ, it has to be like OBJ A, B, C, D, E. But this is like a set of answers. So can you give us an example of a question that we see often, like almost every time,
The
that we've not with?
the question they will usually come is they will give you a network, maybe from what I have seen, they'll give you a network and ask you what is the second network when you subnet this to maybe they give you this kind of question, and it will be like, what is the third network with a subnet mask of /28. So they will just give you /24 and then see what will be the third network when you subnet this to /28. Please mute.
Ndine mama.
Hello?
Aboki. Does that answer your question? And another one that I've seen them ask is they will give you an IP address and then ask you what is the network ID for this IP address. So they may give you 10.10.10.10/28 and ask what is the network ID of this network, of this IP address, because this is obviously a single IP address. So now I ask you what is the network ID or the broadcast ID of this network or of this IP address. Or they will give you a subnet and ask what is the fifth or the first usable IP in this network.
Please, I don't know if we still have more time, like probably there's an extension for this networking class. If you can get us like 2 or 3 questions that we can do together, because why I'm confused is because all the things that we've been doing is dependent on the numbers of network that we're asked to find, like create network with 10 hosts, 6 hosts. So we've not really seen the actual question. Do you understand? I don't know if you can get us probably 3 questions that we can do together.
Yeah, that's because number one, I'm not teaching you to write an exam. I'm not teaching you based on an exam question. I am teaching you what is applicable in the industry.
Okay, ma.
So I'm not preparing you for exam. If I prepare you for a CCNA exam, you think I'll be teaching you this way? Nobody goes into this in depth like this to teach you a CCNA exam because you are preparing for exam. You're not preparing for work. They are 2 different things. All right. Any more questions?
This one is
From his question, I believe if you understand the details, like if you understand it very well based on work, you can answer the exam question.
Yeah, you can answer it as long as you understand how subnetting is done. If your question come in any way, you will answer the question. The problem is if you don't know how subnetting is done, and then you go to answer a question. Like you said, don't worry. I'm going to find. I have a CCNA past questions. I'm going to find. I'm going to couple up a question from there, and then I will make it one of our Kahoot quiz. I'll put it as part of our Kahoot quiz. Though I do get questions from there. Some of these questions you see me put on Kahoot is coming from past question papers. But maybe next week I'm going to focus on subnetting questions from CCNA past questions. So you see how the questions come.
Thank you, man.
I think with the assignment you want to give us, if we are to do subnetting, if he can do this.
I think your network just cut out because I can't hear anything again. But after this class, like he was trying to say, you're going to get an exercise. And when I give you exercises for fundamental networking, be ready to do subnetting because all my questions come with subnetting. That is how I make sure you practice it over and over. Because you cannot design your network if your subnetting is not right. So after this class, you're going to get your exercise for the week, which will be subnetting and network connectivity. You're going to do the subnetting, and then you will do the design, the topology design by yourself. So that I know do help, because if you cannot do the subnetting, there's no way you're going to do the design.
Can I ask a question? Sorry, ma.
Go ahead.
So I get something now. I don't know. Is it that see this create network with 10 hosts? Is it that for instance, if we're given a question, for instance, we can use any kind of host to just break it down?
What do you mean by any kind of host?
I mean any kind of like since okay, let's assume we're going to look for the second network with this IP address. We can create a network with any kind of like maybe 5 hosts, 6 hosts, just to get the numbers of like the third IP address.
It depends on the subnet mask they give you.
Okay.
If they give you the subnet mask, you will be able, if you have mastered if you've mastered the net what do you call it, subnetting, and they give you the subnet mask, you can easily know how many bits we are borrowed to create that subnet mask. So if you give me a subnet mask of /30, I already know, okay, to get /30, at least 6 bits we are borrowed. So if you borrow 6 bits, the only thing that is left for the host will be 2. So their increment must have been in the number after 2 hosts for them to get /30. So the increment for /30 obviously is going to be 4. So if you know the increment was 4, then you'll be able to determine the network, the start network and the end network of that subnet you're giving. There's a formula that they have on finding the actual IP address or the number. Maybe they ask you to get the second or the 10th IP address in a subnet, but I don't have that formula offhand right now. I've tried to master that formula, but it's not something that I take note of, because I know that I can easily subnet and get my answer. But I'm going to look into that formula and see if I'll find it somewhere. But trust me, it's useless if you can do subnetting. That's one of the reasons why I've not taken time to take heed of it, but I know it do exist somewhere.
Excuse me, I wanted to ask a question.
Go ahead.
Since you're actually showing up what is going to be as a workplace, is that how they kind of give you um like a network topology to write and to design your network and then separate them as a subnetting? Is
Yes,
that how
that's
you?
what you do. When they give you a network topology to design, 80% of them they will give you just one network. So you are the one that will break the network into how many subnets that you want it, or how many segments you want it, depending on the requirement. It could be that you want the subnets to be isolated, they don't need to communicate, so you need to break the IP into multiple subnets, assign each subnet to each department, and block communication between them.
Okay. So did we have you done that? Like how you block the communication between them, or we haven't reached that part yet?
If not done that, that is under network security.
Oh, okay. Fine.
We talk about how you filter and control the flow of traffic in a network. That is under network security. Or we talk about ACLs and talk about security policies.
All right. So talking about how you want to separate them, like if you're talking about segmentation, how you want to separate them? Is it like you're gonna have a tool in an environment like this enterprise environment that you're gonna work on, or you're gonna have your notebooks or something like that you do on it?
I'm
I'm
trying to
actually.
understand your question, even though I understand, but I'm trying to fake ignorance of it. That's the problem.
Hmm.
I'm trying to fake ignorance that I don't understand, but I do understand your question. But we'll get there. We'll get there when we get there.
Oh,
When you do the segmentation for our program, that is handled under network security. So if you are doing network security, you're going to have access to a firewall to do this. But like I say, we'll get there when we get there.
Okay.
You're asking basic questions that we covered in our onboarding session. See why I say when you miss a class, you draw us back. And when you don't go back to review a previous class, you also draw us back. There's a reason we record sessions. If you guys will not be utilizing the recorded sessions, then I don't think we should continue recording. Because that is why we record sessions, so that I know there is no way I expect you to. No, I'm not talking on behalf of your question, Sabas. I'm talking about in general. Because if you don't go back to review recorded sessions, I don't expect you to grasp everything in the same day. Nobody does that. Nobody is setting that expectation. That is why we record the sessions, so that it becomes a reference material for you to go back to. But when you don't do that, trust me, you draw us back a lot on the next class. As much as we are patient enough to answer all the questions, but you are chipping into the time that we have. Now, we already spent 1 hour here, and we have only 1 hour left to do the designs. And we've not even gotten to the designs yet. So if you can be utilizing the recorded sessions, that will be helpful. If you're not utilizing it, then I don't think we should be wasting resources recording it, but it doesn't make any sense.
Ma, please record.
Any more questions here before we move forward? Questions. All right, so we are going to use these networks that we created to do a little design and set up communication along the designs or along the networks. So let me go back to my packet trace. I'm going to stop sharing and then I reshare my screen. Please, if you're putting a question on the chat and the question is for me, please note that I'm not going to see it until I go to the chat. So if you can ask your question, that would be helpful, please. What am I sharing? No, not sharing the right thing. I want to share screen. Screen number 1, screen number 2. Okay. I need to flow away, flow out of my state. So here we are on our packet tracer. Now we are going to, just as we did yesterday, we are going to be creating 4 networks. We already created 16 networks, so we're going to utilize 4 of them. We're going to utilize 4 of them. And then I have, we had 10.10.10.0/28. Then we had 10.10.10.16/28. Then we have 10.10.10.32/28. And we have 10.10.10.48/28. So these are the part of the networks we just created. So we're going to be utilizing these 4 networks. So let's pull up a design. Each of the network, we're going to assign 2 computers just so we make it easier for us. Let's name the networks. Maybe this one, we call this one IT network. And this one, we'll call this one HR network. And this one, we'll call this one logistics network. And the last one, we'll call, let's say, management network. So the IT team will be on the first network. Anybody that is from the IT team, their computer will be plugged here. HR will have the second network. Logistics will have this network. And then the last one will be for the executive, which is the management. Now remember that, as we discussed, this is a switch. And a switch allows us to connect computers of the same network to them. By default, emphasis on the word by default, because there are configurations you can do on this switch to break that behavior. But by default, you can connect computers of the same network to one switch and all of them will communicate without a problem. So let's go ahead and try, even though we did this yesterday, but let's go ahead and do it again. So let's say we're going to make the cabling here. I'm going to do auto cabling. These are computers. Let's put these 2 computers on a network. Let me add one more computer just so it makes sense that I have a switch. So I have these 3 computers right here. I'm going to put them on the super network we started with, 10.10.10.0/24. So these computers right here, I'm going to give them IP addresses from this super network. This is what we started with before we broke this into 16 networks. So for this guy, I'm going to give this guy .10. This guy, I'm going to give this one .20. And this guy, I'm going to give it maybe .40 right here from this network. So let's go ahead and give the computers that IP address. Starting from PC0, go to desktop, go to IP, make sure it is on static, and then we do 10.10.10. We're going to give it .10, and then I move. You see, when I move to the subnet mask, the computer understood that 10 IP addresses belongs to belongs to class A IP address. So it automatically gave me the class A subnet mask. But because I'm not using the slash A or class A subnet address, I can change it to what I want, which is a class C subnet mask. So this I will change to 255.255.255.0. That is representing my /24. So I go to this one, I give it an IP 10.10.10.20, subnet mask 255.255.255.0. And then on this one, I give it another IP 10.10.10.40. What did you say? 40 something here? .40. Subnet mask 255.255.255.0. Now they all have an IP address. Let's see if they can communicate. These 3 computers got an IP from this subnet /24. By default, I expect them to be able to talk to each other. If I do ping 10.10.10.20, I should get a response back because the computer recognized they are on the same network. If I ping .40, I should get a response back. So both computers or the 3 computers are communicating. just because one, they are on the same network and they are plugged on the same switch. So they recognize each other. Let's go ahead and break these computers into multiple networks. So instead of giving them /24, we're going to give them /28. If you hover on this computer, you will see the IP address says /24. If you hover on it, you see it says /24. That's what we have. So I'm going to change it to /28 so that it can reflect the subnetted networks. So I'm going to come here and change. The only thing I need to do is change this guy from 255.255.255.0 and change it to 255.255.255.240. I'm going to copy this so I don't need to retype it. Go to this computer, put the same here, and the last computer, put the same right there. Now, the computers that we are communicating just a few minutes ago, let's try and see if they will still communicate again. Now you see the communication is broken. Unexpected behavior. Because now the computer understands that this guy is no longer on my network. Because if you look at, this is .10. .10 falls under this first network. This is .20. .20 falls under this second network. It's an IP on the second network. Then 40 is an IP on the third network. So they are no longer on the same network. So there is no way they will communicate again. So for them to communicate, we need to, first of all, isolate the networks for easy design. Hold your question. Hold it, Solomon.
Okay.
So we are going to isolate this so that they can be on different network and identify the computers or IPs that are on the same network, and they will be able to communicate with them. But for us to communicate between network, which is intercommunication, we are going to need an extra help for them to intercommunicate. Solomon, go ahead and ask that question.
No, when you are saying concerning the 20 on the second network, and the thing was not clear. My network was breathing, so I didn't get it. That's why I just have to do it back.
We listed the IP range for each of these networks now. The first one, what is the IP range for this first network? What are the valid IPs? The network start with 10.10.10.0. What will be the range of this network? What is going to range on, Solomon?
But you're gonna range 10.10.10.15.
So anything between what and what belongs to that network. Any IP between 1 to what?
1 to 14.
1 to 14. So this guy is 10.
Yes.
Do you think this guy falls under that network?
Yes, ma. Yes, ma.
Do the same thing for the second network. What will be the range from this second network?
It's gonna that's from 1 to 27.
Now,
It should be 15 to 14 to 27.
huh?
14 to 27.
Again, huh?
You so.
You just told me that the first network is from 1 to 14 for the valid IP address. So I'm telling you, what will be the valid IPs for the second network? This is 10.10.10.16/28. What will be the valid IP range?
could be from that the IP range ends at 31.
What would be the valid IP range for that network?
To be 10.10.10.31.
You're giving me the broadcast ID. What is the valid IP range? Emphasis on the word valid. What IP on this network can I assign to a computer? From what to what?
From
From 16
I'm asking
to
Solomon.
31. But it has to be from 16 to 31.
That is the whole IP address. What is the valid IP range?
Okay.
I think from, please, can I answer?
Go ahead, Emmanuel.
Okay, from 17 to 30.
From 17 to 30. Thank you.
Yeah.
So you can assign anything from 17 to 30 to this from this network is valid. 16 is the first available IP, which is a network ID. You can assign it to a computer. The last IP address is 31, is a broadcast ID. You cannot assign it to a computer. So anything between 16 and 13 and 31, you can assign to your computer, excluding those IP addresses. Solomon, does that make sense?
Yes, ma'am.
So do you think this guy belongs to that network or not?
It does, ma'am. It does.
Okay. Tell me, which of this network does this .40 belongs to? Is it the IT? Is it the HR? Is it the logistics? Is it the management? Where does that .40 falls?
Logistics, ma'am.
Logistics. How did you get it?
I just use my head because
Yeah, explain us from what came from your head. Fast. You're burning time. Tell us, how did you justify your
me
answer?
from 30, from 40 is not up to 48. So I just see it in such a way that the the 40 fall in between 32 and 48. So that's
So
how I just did it.
you say it fall between what?
It fall between 32 and 48.
What is the IP range for that logistics network?
33 to 27.
Huh?
Sorry, 33 to 47.
Valid IP addresses.
Hey.
What is the valid IP for logistics?
Oh.
Come on, you were almost there. You just missed the number, so I'm trying to make you correct yourself. Maybe it was a slip of tongue.
I said 33 to 47. That's what I said.
Yeah, I had it the first time. That's why I'm trying to make you correct that, because it is wrong. You're giving me, I'm asking you for the host IPs in that network, which are, when you hear host IP, it means the valid IP addresses that we can assign to a computer. You are missing a number. Who can help him out, please?
31 to 46.
31. Did I hear 31?
33 to 46.
Sorry. 33 to 46.
33 to 46 is the valid IP. 32 is the network ID. 37 is the broadcast ID. So anything between that can go on any computer. Solomon, does that make sense? Now,
Yes, ma'am.
let me break this network, and we are going to try to assign the first IP on the network to a computer, and we'll see what the computer says to us. For instance, this /24, we know that the first IP addresses in this guy is 10.10.10.0. If I try to assign 10.10.10.0 to a computer, you will see the computer will complain. Let me try that. This is .0. If I put this, you see, you're telling me that invalid IP for this subnet mask entered. Because you cannot assign a network ID to a computer. If I try to assign the subnet map, the broadcast IP address for that first network, which is 10.10.10.31, and I come here and put the subnet mask of 255.255.255.240, computer is not going to take it. It will report to me that that IP address does not belong to a computer because that is a broadcast network. Invalid IP for this subnet mask entered.
Right.
Not just on a computer. If you assign this to any layer 3 interface, it is going to report. So that's why we don't use the first IP address and the last IP address in a network. But anything in between that, you can assign to your computer. Please ask your questions. I'm going to return this guy to 10.10.10.10 and do the subnet mask of this. Ask your questions, please.
I guess I have more of a comment.
Go
It's
ahead.
like, now that I think about it, like all the routers, they usually, when you try to get into them, that last octet is always 1. And that's how you usually access the router. So I can see why that's now reserved all the time.
Oh yeah, because you can't use 0. You cannot use 0. So they will always, many people will always assign the first available IP of a network to the router interface, even though that is a convention, but I mean it's a convention but not a requirement, because you can use any IP in that network on your router interface. Just
Very
make
true.
sure you don't assign it to any other computer.
Got it.
Okay, now we're going to break this. We see that we've assigned IP addresses to these computers and modified their subnet mask to /28. So now they have lost communication because they are no longer on the same network. So let's Kukuma go ahead and break it into multiple networks. So I'm going to break this connectivity. No, I'm not deleting that. So I'm going to bring in, remember I said that by default, a switch will only allow communication between computers on the same network. So if you want to connect more computers on one network, we're going to give each of them their individual switches. Remember, this is by default. This is by default because there are configurations you can do on the switch to break that default default practice or default functionality. But for now, let's stick to the default. So I'm going to get 4 routers, each for each network. I'm going to get more computers here. I'm going to do 2 computers for each network. Go ahead. Oh, that was not a question. Okay. All right, I'm going to do my cabling for each of these guys. I'm just going to do auto cabling because I already know where is landing them. If I don't want to do auto cabling, I can just pick the straight through cable. It will show you all the interfaces on the, if you are interested in connecting to a specific interface, you can do that and then select the interface you want to connect to. So let me say I want to plug this on a ET0/10 on the switch side and then plug it on the computer. This comes handy when you have what we call port security configured. You'll be able to know the interfaces that has port security or port fast configured on them. But that's a story for another day. All right, so let's group the network. So this guy is going to be the HR network or IT network, which is /28. Let's just call it IT. And then this guy is going to be HR. This guy is going to be logistics. And this guy is going to be management. All right. So let's go ahead and assign the computer's IP address on their individual. I want to move this forward. This is the IP range for each of this network. But let me just add it here so it will be easier for you guys to spot. 10.10.10.0/28. And then this guy is going to be management is 10.10.10.48/28. Logistics is 10.10.10. Logistics is 32/28. And then HR is 10.10.10.16/28. All right, so these are the networks for each of these. So for now, we are leaving it at 2 computers per network. But you know that we created a subnet that can accommodate 14 IP addresses. Hi, Cybergoris, thank you so much. So if you have up to 14 computers over here, you can actually assign them an IP from here. But know that it's not going to exceed the number of networks or number of usable IPs that you have on each network. So let's go ahead and give them IP addresses from here. Let me see who I'm going to pick on here. Felix, I'm picking on you right now. Give me an IP address from this network. Remember, for this computer, we already assigned it .10. Give me another IP for this computer from this network. Felix.
Yeah, 10.10.10 dot 10.
I already have .10 assigned to a computer. Now let me try and give .10 and you will see what it's going to say. If I put .10, you see, address is already in use.
Oh, okay. Let's take 20.
Go ahead.
Let's 10.10.10.20.
Are you looking at the IP range?
Yeah, the range is /28.
Okay, so what is the valid IP for that network?
Yeah, I think it's 10.10.10 dot 13. Let's say if you take 13, it will be good.
13. What is the subnet mask?
255 dot 255 dot 255 dot 0.
If I'm not typing, it means you're wrong. We're dealing with
240.
/28.
Yeah.
240.
240.
Yeah, 240.
Thank you. T1, give me an IP address for, I thought I gave this. Okay, this is the new network I added here. So give me 2 IPs from HR that I can add to these computers.
Give me one second.
Okay.
I'm processing.
Okay.
So, pictures. Okay. Oh, 10 dot 10 dot 10 that wow, this is really hard.
There's no digit like wow. It's not a digit.
Okay, wait. 10 dot 16? No. Oh, dot 30 work?
You tell me.
Let's try 30.
What? No, I didn't hear you well. That's why I'm asking. You say let's try 30?
Yeah.
Okay, if you say so. What would be the subnet mask?
Subnet mask will be 255.255.255.240.
Thank you.
Maybe.
You're right. Now give me another IP from this network for the other computer. Come on. 10,
10 dot 10 dot 10 dot 10 dot oh my gosh.
Okay.
I don't know.
What are the valid IP addresses for the HR department?
HRs between 1 and 14 maybe.
I said HR department.
HR. Okay, wait. Oh. I don't know. I'm lost.
You can see the HR network, right? The HR subnet.
The 16/28.
Okay, that is the subnet. So what is the IP range for that subnet?
Between 17 and 31 maybe.
Valid IP address. You were a number off, so that's why I need you to correct yourself. What is the valid IP address for that subnet?
Oh, 17 and 30?
So anything between 17 and 30 goes here.
Okay.
Anything from 17 and 30 goes, because those are the valid IP you can assign any computer on the HR department. So give me an IP. You already gave me 30 for the other computer. So give me another IP.
29.
29.
Excuse
Thank
me,
you.
before you proceed, may I?
Go on. Hold on. Let me finish with that. Just a moment. Just a moment, please.
Just about this because he asked about 31. You said no. I don't know what. I just
Yeah,
know what.
because 31 is the last IP address on that network, and we can assign it to a computer. Is the broadcast IP. So the valid IP, anything between 16 and 17, 16 and 31, excluding 16 and 31, which is 17 to 30. So anything between that, you can assign to your computers. Does that make sense?
Yeah. I thought it was the broadcast was on 32 in this case.
No,
I keep misunderstood.
no, the broadcast 32 is already on another network. It's no longer HR network. HR network ends at 31. So 32 is another network. And for subnetting, IPs must not collapse, must not conflict, must not enter another network.
Okay. All right.
All right. Do you want to give me the subnet mask?
255.255.240.
Thank you. Okay, Abbas, let me come to you. Give me the network for logistics. I already assigned 40 here. So give me another IP from logistics I can assign this computer.
It's gonna be 10.10.
Mm-hmm.
Dot 10. That you said you already assigned 40, that 42? No, 43, yo.
That what?
That 44.
44. It's fine. 42 works. 41 works. As long as it's not for anything from
Yeah.
48 up. Anything from
Yeah.
47 up works. Give me the subnet mask.
255, 255, 240. No, 255 and 240.
Thank you. Solomon, give me an IP address from the management network for this computer. Is he still on this call? Oga, give me IP, no the scammer.
Can you hear me?
I can hear you. Go ahead. Are you trying to fake poor? Are you trying to fake poor network?
It's faking the
Because
network.
I can actually hear you very well.
I'm not faking network, but I think that honestly, me, I don't know this one. I won't
You don't know
just
the
try to catch up from what else. I don't
IPs
know
from
this
the
one, to
management
be
network.
honest.
Now look at the management network. What is the IP range for the management network?
Management network.
You can see the management network there, right? The MGT network.
Yes, ma'am.
What is the network there?
10.10. You know
Go
right now?
ahead. You said I
Okay,
should type.
10.10. No, I said you asked me the IP, right? So
Yeah,
it's
give me what is the
10.10.10.
network address for management? Give me the full network you have there.
Okay, the first I have here is 10.10.
Mm-hmm.
Dot 10 dot
Mm-hmm.
48 slash 28
So
slash
what is
28.
the valid, or let me not talk about valid. What is the IP range for the management network following that subnet mask?
It's from 33 to 47.
Okay, when you carry 33 come into this network, we start for 48. The network already start with 48. So where did we get 33 from? Or are you mixing up the
Sorry,
networks?
my bad. I'm mixing up. My bad.
Okay. Oh yeah, go ahead and correct yourself and give me what is the IP range for that management network?
You choke me.
You know, go choke, you will answer it. Look at the network. This is .48. What was our increment when we did this subnetting?
Or 16.
Our increment was 16.
Yeah.
So what is the valid IP for that network? If you know that our increment was 16. So the next IP address, the next network after the 48 must have been what?
64. The
64.
last
So
one.
62.
what is the range of management network? What were the IP ranges?
46 to
It
64.
for
Solomon,
for my 49 to 62.
49. Is that the IP range or is that the valid IPs? Which one?
Valid IPs.
Valid IPs. So give me an IP
Yes.
from that valid IP for this computer.
63.
10.10.10. The what?
The 62 slash
Give me an IP.
63, man.
You just told me the valid IP range. Give me an IP from the valid IP range that you mentioned.
Okay, 49, man.
49. What would be the subnet mask?
38 slash 28.
Hmm?
The subnet max. Okay. Wait, hold on. 225.
It's
The
not
255.
2254, it's 255.
255, sorry.
Mm-hmm.
The 255.
Mm-hmm.
The 255 or 240.
Or 240. Does it make sense how you found that IP address?
I was just struggling with it.
I know you will struggle with it. Like I said, I'm not expecting you to grasp it in one day.
Is there any guy this, eh?
Like I said, I am not expecting you to grasp it in one day. But if you can do, what did I just do now? Wait, I've just messed up something. This guy is on this network. So you gave me 49, so I'm just going to put this guy on 50. What network is this guy on? 40, okay. All right, so we have assigned IP addresses to these computers based on their subnet. If I ping across them, ping from here to here, I have success. If I ping from here to here, I have success. If I ping from here to here, there is a success. If I ping from here to here, there is a success. So the computers on the same network are able to communicate without a problem. But if I ping from here to here, only God will help me. If I ping from here to here, there is no magic. It's only in Nigeria that magic will happen.
It happens, man.
Sorry?
I say, what if it eventually happens?
Anything can happen in Nigeria. After all, what God cannot do does not exist. Okay, so now we have created these 4 networks. Our goal is to see how we can make these networks communicate between each other. And if you're going from one network to another, you're going to need the help of your router for you to move. Remember the function of a router, as Chidima said, it helps to move traffic from one network to another. A switch allows communication between one network by default. If you're moving between networks, you're going to need an external help for the computers to carry the networks across. Please mute if you're not talking to me. So let's bring in a router here. I'm going to find a router that has at least 4 interfaces because I don't want to go through. How many interfaces does this guy has? 3 interfaces. It's going to need me to start putting interfaces now.
So how did you notify? I mean, how did you get to know the interfaces?
I will talk about it. Don't worry.
Okay.
I just want to find if there's anyone that have a default for this. Where is that router? The router is missing here. Okay, this router. This guy have 3 interfaces, so I don't want to have to go through adding an interface. That's my problem. Because that is, like I say, that what I will end up doing now. Because if this one does not have 4, I'm not sure this one have 4. This one has 3. So I even have 2. Beg, go. And they have not fixed that bug that exists in Packet Tracer for over last 2 years. This guy have just 2. Okay, it looks like I'm working with an empty router, but let me bring one router and tell you what I mean by interfaces. So this router, I need to connect these 4 switches to a router so that it can allow for communication between the whole networks. But for that to happen, it means we need to plug one interface from the router to each of the network. Let me pull my board. It will be easy to explain this on a board. I'm going to reshare my screen. Guys, I know I said it before. You please don't put your questions on the chat. I won't be able to read it if I am talking. Please ask your question out. I
I'm
see I
sorry,
have
what are we trying to
about
do?
27 questions that I don't even know if it was directed to me.
What are we trying to do right now?
Okay, we are trying to connect the computers to a router so that we can allow intercommunication between the networks. Does that answer your question?
Kind of, sort of. I'm just wondering, are we using the router as like a firewall type of
Oh
deal?
no, nobody's talking about firewall right now. We are using a router as a router. Okay, so this is what we have so far. We have a switch right here. We have another switch right here. We have a third switch. And then we have another 4th switch. This guy is IT. This is HR. This is logistics. This guy is management. And we understand that we have plugged computers here. This guy's IP was 10.10.10.0/28. This was 10.10.10.16/28. This is 10.10.10.32/28. And this is 10.10.10.48/28. So we've assigned 2 computers to each of these networks. And we were able to confirm that the computers connected on the same switch, on the same network, are able to communicate without a problem. So what we are trying to do now is how to get IT to talk to HR, get HR to talk to logistics, get logistics to talk to management, get management to talk to IT, and allow for all departments to communicate. Because at this moment, they can only talk to those plugged on their switch and having the same network with them. And that can be achieved if we bring in a router. A router is a device that allows us to route traffic from one network to another. By default, your switch will only communicate within the network. There is no way the switch will go and communicate with this guy. If you say you want to do a connection like this, it's not going to work. If you say you want to do a connection from this switch to this switch, or do this and this is a layer 2 switch. There is no way it will route traffic for traffic on different networks. It doesn't have that capability. A switch intelligence only ends within the network. So if we need to communicate intercommunication for the networks, we need a device that has the capability to route traffic on all this network. And that is where your router comes in between here. So you get your router, you plug it here, and then connect the switches to the router. If you remember when we did network topology, what type of topology is this? Who can tell me the type of topology this is?
Is that not a ring?
This cannot be a ring now.
I was gonna say star.
It's a star topology.
It's star topology.
The start topology.
The star topology, because we have this central device where we are connecting our switches
It's a
on.
start topology.
Yeah, it's a star topology. So this is what will happen. We will now have the router connect individual switches to this. Because the router routes traffic based on IP addresses, it needs to know which network the traffic is going to and which network is the starting network. To ensure that the router is able to recognize all networks, because the router is a layer 3 interface, it will be able to take in IP addresses, unlike a switch. A layer 2 switch, you cannot configure any IP address on it. But for this router, you can specify the IP address for each of these networks. That is how the router knows the IP network that it is responsible to route traffic to. So to make sure that the router recognizes IT, recognize management, recognize logistics, recognize HR, it is not enough for you to just connect the switches to the router. That is first step. The second step is to tell the router what IP address is that interface responsible for. So that is where each of the interface, we are going to assign it an IP from the range of that department. So for this one connected to IT, on this router interface, you're going to take one IP address from this network and assign to the interface. You take one IP from the management network assigned to this interface. If you take one network from here, assign it to this interface, it will recognize the logistics network. And then you take one IP from HR and assign to this interface, it will recognize the HR network. That way the router understands, okay, right now I am connected and managing 4 networks. So I know where each of the networks are located. Ask your questions. Ask your questions, please. Silence is consent. If you keep quiet, I want to take it you're with me. And I will come to you for a question. If you will not ask me, I will ask you. T1, I come to you. Tell me, on the
Yeah.
IT network, give me one IP address that I can give this guy. Remember, we just give me any IP address. We will address the conflict later. Give me one IP from IT that I can assign to this router interface.
From IT. Okay. 10.10 dot 10 dot 29.
This
No,
is
no.
0. This is 10.10.10/28.
Oh, sorry. 1.
We can do .1. That's fine. .1 is
Okay.
fine. Hakim. Hakim is here, right? I don't think it's
Yes, I
Hakim.
am.
I
Yes,
think
I
it's
am.
Hakim. Tell me one IP from management that I can assign to this router interface.
10.10.10.7.
This is 48/28 though.
Okay. Sorry. Dot 31.
This is 48/28 though.
48/20. Sorry. Dot. Let's give it 52.
52, that will work.
Yeah.
Solomon, give me an IP from logistics that I will assign to this router interface. You cannot come and fake poor network. Oh.
Hello?
Solomon, is it still here?
He's here. I'm not faking politics. I'm just. I'm looking at it.
Give me an IP from logistics that I can assign to this router interface. Please, if you're not talking to me and I'm not talking to you, mute. That's it. Mute. Oh. Oh my goodness. Where is
Go
he?
ahead.
Did you mute?
Hello?
Is he muted?
Jesus.
Let me find him and mute him. Where is he?
Sorry, ma. I've muted. Sorry, ma.
I muted and I'm still talking. Wait, did I stop sharing my board? Are you still seeing my board?
Yeah, we can see
Yeah.
it.
Yeah, we can
Okay.
see.
All right, Solomon, tell me, IP from logistics I can give to this interface. Abbas,
Okay.
give me an IP I can assign. Solomon, be thinking of HR. Abbas, give me an IP for logistics. One IP from there I can assign here.
Logistic is gonna be 10.10 dot 10 dot 34.
Thank you. Solomon, give me an IP for HR.
10.10
Mm-hmm.
.10 .20.
Thank you.
Huh. Lucky me. I just followed Abbas because I
Good
noticed
one, good
that
one.
I noticed that at 32, the only difference was 2. So me, when I came here at 16, the expected difference should be 2. So I just added that 2.
That is not correct. That is not how we got the IPs. That is manipulation.
That was how me I got my.
You can't be doing that because it doesn't work at all times. Please, you need to know the valid IP in the network. For HR, valid IP is 17 to 30. Anything between here will work. So in logistics is anything between 33 to 46 will work. So if Abbas would have said the 14, you will follow him and say what? Please, you need to know the valid IPs in the range. It is not about manipulating units with adding 2 or adding 4. That's not how you work.
I want to say something.
Go
An
ahead.
observation. I don't know.
Abbas, thank you.
I was thinking the .20 it will assign it to a PC. Can you also use the same IP for?
No, we cannot. That's why I said because I don't know the IPs on the PC. So we are gonna make that change.
Okay.
But you cannot assign it to this if it's already assigned to computers.
All right.
So now we have assigned the interfaces to IP address to the router interfaces. That is the second step. The first step is introducing the router and doing the cabling. The second one is knowing the IPs to assign to each of the interfaces. Then the third one is telling the computers how they will get to the router. Remember when we gave the computers IP, we gave them just the IP and subnet mask. So with that detail, the computers will be able to communicate with computers on the same network. But you see that when we try to talk to computer on another network, the communication fails because the computer understand, number one, this guy is not in my network. Number two, I don't even know how to send my packet for people that are outside my network. So we need to tell the computers how they will forward traffic that are not meant for their network. Because if this computer wants to send a traffic to somebody in management from IT now, it needs to go through the router and then hit this switch before it gets here. But you need to tell this computer, if you receive a traffic or if you are sending a traffic to someone that is not on your network, because you don't have the permission to send that traffic directly to the person, send it to the router. The router will take care of forwarding it to wherever it is. So if this computer IT, maybe this computer here 10.10.10. Let me say this is .10 is trying to communicate to logistics here at 10.10.10. Let me say 37. That's a valid IP, right? Yeah, that's a valid IP. So you want to talk to this guy. It's already, and these are all /28. So this guy will initiate the packets to 37, but then he checks and find that, oh, this guy is not on my network. So I need to find a way to communicate with this guy since he's not in my direct network. So what will happen is this computer here will now start seeking for a help. Please, how do I send a traffic that is destined to .37? Because the guy is not on my network. And if it's not on my network, I do not have the permission to communicate to it directly. So with extra configuration on the computers, you can tell the computer, if you get a traffic that is destined to an IP that is not in your network, you have the permission to send that to your router interface. 99% of time, it will be your router interface, but in a complex enterprise, it will not be. That is why we don't call it the router interface. Rather, we'll call it the default gateway. So you tell the computer, if you get a traffic that is destined to an IP address that is not within your network, feel free to send that packet to your default gateway instead of you dropping the packet. Because what is going to happen once the computer decides that the traffic is not on its network, it will go ahead and drop the packet. But to prevent the computer from dropping the traffic, you tell it, please send it to your default gateway instead. The default gateway will be able to take care of it and route it anywhere. So you will come to the computers and set up a default gateway. And in this our topology, the default gateway we are going to configure is going to be whatever IP that we've configured on the router interface that is facing that network. So something like IT, if we say we are giving the router interface 10.10.10.1, we need to come to the computers that are behind the switch in the IT department and set up a default gateway pointing to 10.10.10.1. So that way, if any computer in the IT department gets a traffic that is destined to anywhere except for its local network, it will just send the traffic to the default gateway, which is this router. That is how the traffic will get to the router. Once it gets to the router will take care of the rest of the communication. Ask your questions.
Yeah, I have a question.
Go ahead.
Now go ahead.
Go ahead.
All right. So the default gateway, are we going to assign it to every computer on the network, like from
Yes.
the IT to the management and the HR?
Yes. For each of the
Okay.
computers, you will assign it the appropriate default gateway, which
Yeah.
is
Okay.
the IP address configured on the interface that is facing that network.
Right.
So for
So
management, we're going to configure .52 as their default gateway. For logistics, we're going to configure .34 as their default gateway. And for HR, we're going to configure 20 as their default gateway.
so when we configure the default gateway for every department,
Mhm.
um, the router is gonna enumerate all those gateways, or is it going to be translated into one gateway for the router?
The router already recognized once you configure the interface, the IPs on the router interfaces, the router takes in charge of those networks. So once it receives any traffic that is destined to any of that network, it will check what we call its routing table to know which of the interface controls that network, and it will send that traffic to that interface, out of that interface. Let's say,
Okay.
for instance, we are sending this packet 10.10.10.10 to 10.10.10.37. If you follow the flow of the traffic, let me say this is .10, and the traffic originating from here going to, let's say this is .37. The traffic, if you have a default gateway configured on this .10, and the .10 originates this traffic, because it has a default gateway, it will forward that traffic from here and to its default gateway, which is this interface. So this will go inbound into the router from here. Once it gets to the router will check what we call a routing table and see which of this interface connected to me is responsible for an IP or network that this IP belongs to.
Okay.
So once it checks, because when you are configuring the interface, you also specify the subnet mask on the router. So that's how it knows which interface controls which range of IP addresses. So once you put it, and this guy was configured for /28, the computer understands that that means anything between 33 to 46 needs to go out of this interface. So it will just send it, it will do the processing and forward it out of here. Once he hits the switch will take care of the rest and forward it to this guy.
Right. Makes sense for me now. Yeah.
Mhm.
It's matter of interface. So every interface will,
Yes,
manage the network inside, and
yes.
yeah,
Every
that's all I
interface will
understood.
be manage a distinct network.
A
You
distant
cannot
network. Yeah.
assign two interface IP from one network, the router will reject it. You will get bad mask. Let me say this interface of management and IT, you assign this one .1 and assign this one .2, it will reject it because each interface on a router is supposed to be on a distinct network. You cannot overlap to a multiple networks. Does that make sense?
Yeah, it's very clear.
Ask
Thank
your
you.
questions, guys,
Excuse
before we
me.
go back to our packet tracer.
Excuse me. So that means in order to this all these to be possible, we have to not only we have to configure these end devices, computers, and also we have to configure the router, right?
Yes.
All right.
You're going to configure, we already did part of the configuration on the computers by giving them IP and subnet mask. So we just
Yeah.
need to go into them and also specify the default gateways.
Right.
Then on the router, we will now assign the IP address to the interfaces that we will bring up. Questions, please. T1 Solomon. Who was Akim? Where do I have it? Let me know those. Maybell. I don't want to talk to you because I know you are not even with me. Because I know yesterday's class you missed it. What's going on, board? You missed yesterday's class, so I don't know how you were going to cope with this one.
Who?
Maybell. If she's still at she even left the session, Seth. She's not here again. Okay. Olusola, you've been quiet.
I'm here. Oh, I can hear you.
Ask me your questions.
I don't have any questions. Everything is because I've had a session already. You understand how packet tracer works, so it's just like a refresher for me.
All right, so I want to believe
Just
we
ask one
all on
question.
the
Yes.
same
Is there
board.
another
So
application? Are you there?
go ahead.
Is there another application we can use apart from packet tracer? Because you mentioned something about this bug.
Yeah, there's a bug on Packet Tracer. I thought by now I thought they would fix that bug in 9.0, but I tested yesterday, the bug is still there. But you can use other option is a GNS3 and EVNG. But for you to run those ones, you need to make sure your computer is up to the task because they are resource consuming. Packet Tracer is lightweight. It doesn't consume quite a lot. But if you want to run a more sophisticated simulation, you're going to do EVNG or GNS3, or they are resource intensive. Does that answer your question?
Yes, it does. Thank you very much.
Ezekiel,
I'm
what's
here.
up?
I'm good.
You with me?
Yes.
Okay. Mabel, you keep jumping like a Nigerian network and Nigerian light in and out. All right, so this explains what next we are going to do now. We're going to go back to our packet tracer, introduce a router, cable it to the interfaces, go to the switches, go to the computers and assign them IP addresses for their gateway. No, people should not come in now. Okay, I'm going to reshare my board and we take it from there. Screen number 1, screen number 2, right here. can see my packet tracer, right? That's gonna answer now. Let me know the screen you're seeing.
Yeah, your packet tracer.
All right. So now I was looking for a router that has 4 interfaces because as you see, we are going to do 4 connections to these interfaces. But this guy, if I hover on it, you see it has only 3 gigabit interfaces. It has only 3 interfaces. So our option, if you are running 8.0 or no, 7.2, was to add extra interfaces to this router. But since 8.1, 8.2 versions of Packet Tracer, we're not able to do that. So that is the bug that I was referring to. It will let you to add the extra interface, but you can't work with it. You cannot work with it. So normally, if I'm running into that, what I do is to get an empty router. There's an option for an empty router here, PT empty. This router does not have any interface on it. So you are going to add as much interface as you want. You're able to add as much gigabit interface as you want, as the slots can accommodate actually, as the slots can accommodate. So if I click on this interface, you see there is no interface on it. If I go to the CLI, of this and hit no, and then en means you're enabling the router, and then I do show IP interface brief. Show IP interface brief. See, there is no interface on this router, no single interface, no port. So we are not able to connect anything. Even if you try, go over here, do auto cabling from here to here, there's nothing is coming up because there is no interface on this guy. It doesn't have an interface. So we're going to go ahead and add 4 interface to this router. So if you click on it, go to physical. If you zoom in, let me zoom in. You see where it says off. It's just like you trying to add extra hardware to a device. And 99% of time, these devices are not what we call hot swappable. So they will not be on while you are adding or changing hardware. You need to turn it off. So that is where you come here, you toggle this button, toggle it to 0. It means it's now off. If it is on and I try to add a module to it, it won't work. Let's try it. It's on right now. Let me try to add a module. I usually like to add this a CGE. The CGE is a gigabit interface. So it's a 1000 Mbps interface, which will correspond to what I have on my switch or what I want to use. So I'm just going to drag it, this module, and drop it on any of these empty spaces you see here. Drop it right here. But because this router is on, it will tell me cannot add a module when the power is on. So I need to turn it off. If I turn it off and I drag this again, CGE, drag it and drop here, it will drag. I'm going to drag 4 of them because that's what I need. I can drag extra if I want. Let me drag extra 1 to make it 5 interfaces. So now I have 5 interfaces on this router. I can go ahead and turn it back on. If I hover on it now, you will see I have 5 interfaces available now. So I can use them to do my connectivity. And since they are gigabit interfaces, I want to use the same gigabit interface on the switch. This, our 2960 switch has 2 gigabit interface. It doesn't matter actually if you are using the fast Ethernet ports. This is the fast Ethernet port. The fast Ethernet ports are 100 Mbps. The gigabit interface are 1000 Mbps. So it's all about the speed and bandwidth of the interfaces. if I'm connecting to a router, I love connecting to a gigabit port so that it can match the speed. Because if there is a speed mismatch, this is in a production environment. If you connect 100 Mbps to a 1000 Mbps, the speed for that interface will drop to 100 Mbps. So you are not utilizing what the other interface has, because it needs to function on a bandwidth or speed that is supported on both ends. So if you are doing fast Ethernet port here, and this guy is 100 Mbps, 1000 Mbps, it will drop the speed to 100 Mbps so that it can accommodate the switch side. So if you have gigabit here and you have a gigabit port here, it's better you do 1 gigabit on both so that you can utilize the speed of the port. So since this two has a gigabit ports, I can go ahead and connect a gigabit port to them. And I'm going to be using a crossover cable. No, I'm going to use the straight through cable actually. So if I click on it, I come to the switch, click on the switch. See, down here, I have 2 gigabit ports. So I'm going to choose the first one, straighten it to the router, click on the router, it will show me the available ports. So I'm going to connect it to G0/0 here. I will do that for the rest of the interfaces. Go on the switch, choose the G0/1, go on the router. So when you click on the router, it will only show you the available interfaces that you can connect that to. Now, remember on the first one, we already taken 0/0. So 0/0 is no longer here. What I have here now is 1/0. So I can drop this on 1/0. Take another one from this guy. I have the gigabit port on the switch side, connect it to this guy, 2.0. Take this guy, put it right here, connect it, and put it right here. Don't blame me, I'm not good with designs actually, but I can make it better. You can move these guys up here. No, I can move these guys up here. Why is this guy not going? Okay, let me make this topology look a little nicer. I think I can do better than this. Then move these two up here. Separate them. Now I don't know the one that is 20 and the one that is 10, but I'll find it. This is 49. It's not even any of them. Okay, let's just take out the numbers there. So now I can get these guys. No, I can get these guys, move them over here, move them over here, move them over here. And I can get these guys, balance it very well, balance these guys very well. Okay. So I think it makes it's a little better right now if you ask me. They're still controlling their individual networks. All right, so this is what we have now. This is the same thing we had in our board. So we have done the connectivity from the individual switches to the router. Now, when you do this kind of connection and your router shows red right here, it means that it is not up. It cannot pass traffic. It cannot pass traffic. So we need to go into the router. Let's say, like we said, let's get them an IP addresses for each of these router interfaces. So this guy will give this interface. We agreed on .1 on this interface. And on this interface, I think we said 52. And then on this one, let me make it better. Let me just put it right here for that interface. But note that this is configured on the router side, not on the switch side. So here, I think we agreed on 33 here, or was it 37? Let me just do 33 if it's not assigned to an IP. Or let me do 35 for this interface. And then for this last one, I can do, let me do the first available IP on this interface, which is .17. This is .17. All right, so these are the IPs we'll assign to the router interfaces. Now remember, when you are trying to assign the IPs to the interfaces, you make sure you are configuring the correct interface. If you meant to configure .35 on this interface and mistakenly configure it on this interface, you go troubleshoot, tire, no evidence. Abi you go explain, tire, no evidence. So make sure you are pointing or you are inside the right interface. Now let me pull up my this thing. My notepad. I'm going to type the command that we are going to run here. So you see it. Cisco packet tracer is CLI based. So most of the things you will configure from the CLI. And it's easier to configure on the CLI shell. So you need to learn to type commands. So now we'll start with this interface right here. Let's hover on this to get this interface. This is G0/0. So the interface connected to this network is G0/0. So go ahead and set up the command for that interface. Now for a Cisco packet tracer or Cisco devices, before you configure them, you need to go into configuration mode. And to go into configuration mode, if it's not already enabled, you can enable the router by typing enable. One good thing about Cisco device is that it understands short forms. So instead of me doing enable, I can just do en. It works too. En is me enabling the router. And then I go into configuration mode. Most networking devices has two modes. We call it operational mode and configuration mode. Operational mode is where you're going to run a show commands to see what you want to see. But if you want to do a configuration, you need to go into a configuration mode. So now to go into a configuration mode, we're going to type Cisco environment. Sorry, I'm mixing the commands with a firewall. So I'm trying to get the right one for Cisco. Configure terminal. Configure terminal. You can do configure terminal, or like I say, you understand short form, or you can just do config T. But the full word is configure terminal. It's understanding. Now we are entering into the configuration mode. We are now in the global configuration mode, but our aim is to configure this specific interface here. So you need to go inside this interface and configure it. And the command for that is you call the interface, it can be interface G0/0. Or if you can type the full name, maybe gigabit, I don't know, gigabit interface or Ethernet, whatever that is. You see Ethernet. I don't know the full name, but if you know the full name, you can type it. For me, I usually do short form. So interface G0/0. This shows I am calling this interface. See, if I hover on this, you see it says GIG0/0. You can type it like that, or you can type just G0/0 because it is a gigabit interface. If this was a fast Ethernet interface, you're going to do F0/0. But this is a gigabit interface, so I'm going to do G0/0. This command shows I want to go inside this interface and configure it. So any configuration I do right now will apply to this interface. Now I'm going to assign the computer an IP, the interface an IP address, which is going to be IP add. This is a short form for IP address, but IP add will work. IP add, the IP I want to add is 10.10.10.1. Then you give it the subnet mask, 255.255.255.240. Because this interface is administratively down by default, even if you configure the IP, you need to come and bring up the interface. The interface is what we call administratively shut down at the moment. So for it to be able to pass traffic, you need to bring the interface up. And the command for that is no shut, which is a short for no shutdown. Why I like Cisco environment is when you configure something and you want to do opposite of that, just add a no in the front and it will do the opposite function. If I want to, if I enter this IP address and I decide, okay, I don't want to give this interface the IP address again, I just have to put a no in the front here and it will take out the IP address that I entered. All right, so this will be the command we are going to run on this interface. I could just copy this and open this router and paste it, but I'm not going to do that. So I'll go into the router and configure it, and you'll see that. So go to the CLI. If you are configuring the switch or the router for the first time, it will try to do initial configuration and walk you through that part. I do not do that because I want to do my own configuration myself. So I will just say no here. And it gets me into the regular mode. I'm going to bring this thing side by side here. Okay. So this is the command we are running. This is our CLI. This is our router CLI on the left over here. So we'll start by doing EN, which is enable. And then I go into configuration mode, config T. Now you see the prompt has changed. Now it shows I'm in config mode. The prompt has changed. But I am not on the interface yet. But before I go into the interface, let me show you what the interface looks like at this point. If I do show IP interface brief, these are the interfaces we have. Show IP interface brief is a command you use on the Cisco device to view the status of your interfaces. So right now you see our interfaces are administratively down. No IP address assigned to any of them. They are all unassigned. So let's go ahead and bring up, we are working right now on this interface, this first one. So let's go and give it an IP address. We'll go into that interface, do interface G0/0. The prompt has also changed, as you can see. So I'll give it the IP address, IP add 10.10.10.1, give it a subnet mask 255.255.255.0, hit enter. Now, if I view that interface status again, you see now the interface has an IP address, but it is still administratively down because we need to come and bring up the interface. So I'm going to come here and do no shots. But before I do no shot, let me move this over here. So watch the interface come up once I issue no shot. The interface is still shut down. That's why it is still in red right there. Just a moment, let me perform this. So I'm going to go ahead and issue no shot, and you watch the interface blossom to green. No shot. There it is. So the interface is up right now. If I issue that command again, do show IP interface brief, you see this guy, it says both are up. Status is up, protocol is up, and it has an IP address. See, everything here will transition to green. Ask your question before we finish the rest of the interface, because the rest one I will just do a copy and paste. Ask your questions. Let me type up the command for the other interfaces. Interface. What interface is this? G2/0. So I'm going to go into G2/0, give it an IP address, which is IP add 10.10.10.52 255.255.255.240. Issue no short. Then go to the other interface. What interface is this? This is a G3/0, so this should be Gaduna. G1/0. Okay.
Hello.
Go ahead.
I noticed that the what's it, the subnet that you used, the first IP that you configured, it was 255.12.12.0 you used,
The 0?
not 240. Yes.
Are you serious?
And it still work.
Oh yeah, it will work because the other interfaces have not been configured. So it's only one interface that I've configured. Let me see. Oh yeah. It will, if I try to issue another IP from that subnet to any of the interface, it will fail. So let me correct that. Go here, put a no in the front, take out the IP, and then get the command back to 240, take out the no. There you go. That should fix it. I do show what? Now the commands are messing up in my head, but I'll find it. Do show run. Yeah, do show run. Yeah, so it has the right IP address right here. Okay. It's gonna work as long as that is the only interface that I've configured it on. So this guy, we are on G0/G1/0, which is down here. And we have decided to give it 17. So this is 10.10.10.17. Two 255.255.255.240. Issue no short. Then I go to the other interface, which is interface G3/0. Issue no shorts, and I find IP add. So it doesn't matter the order you do the command, it will still work. .35 255.255.255.240. All right. So I'm just going to copy these commands. After that, let me do show IP interface brief. So I'll copy these commands, go to the router, and I'll paste it right here. Something did not run right. Yeah, this did not run right. So we're going to reconfigure this interface. This one. So I will go back into this interface and rerun the IP command. There you go. So if I do show IP interface brief, we'll see that all our interfaces are now up and configured on the switch side. Yeah, I corrected that. So you see all our interfaces are up and configured. So now the router interfaces are all showing green. So we are done with configuration on the router side. Please ask your question. Ask your question, oh. T1, Mabel, Ebas, Akim, Solomon, Felix. Ask your questions. Monarch, you're asking me if I can configure Ether channel. You see me doing subnet and you're asking me for Ether channel. And I try to fear God though. Guys, questions, so questions before I finish up. I know it's been a lot to take in, but trust me, you can do this. T1, are you here?
I'm here. I feel like the information just need to marinate because it's just too much.
Solomon.
I'm here. I'm here.
Ask your question.
I'm I'm here. I'm watching. I'm here. I'm watch. I watch.
Ask your question.
Hey.
It's not magical. There's no magic here.
I don't even know how to put my questions here. That's the thing. I'm trying to figure out the questions.
Felix. Felix. Is he still here? Abbas, are you still here?
Yeah, I'm here. So we just did the interface is one, right?
Yeah, we brought up the 4 interfaces on the router. All of them.
Okay. So now after that, that's when we're gonna not okay, everything is just connecting now, but we have to um for yeah, we have to do the default gateway for other devices now, right?
You got it.
All right.
That's the next thing now to do.
Okay.
All right, so we go to the computers and assign them the default gateway that we've configured on the routers. We'll start with this guy. This guy, we're going to give it, see where we say default gateway right here. So you come here and give it the default gateway. We have 10.10.10.1. I'm going to copy that so that I can do less typing. Then I open this guy. The same one because they're on the same network. But for this guy, I'm going to give it 52. This is why it's very helpful to learn DHCP. But otherwise, I won't be doing this. This guy is on 35. So I take this guy and also give it 35. Then these other computers here. What number do we have here? 17. Then open this one and give it 17. All right, so we are done giving the computers the default gateway. Now you see that if we do a communication from any of these computers from here, you see the traffic will first of all get to the router. The router, if there is no app, this guy is going to app, and then before the traffic will move from here to wherever it wants to go. So if I do a screen test, I can just ping from here to here. I can confirm that the same network are still working. The same network will work from here, I get a success. If I ping from here to here, I should get a success. Let me try it again. I know why the first one failed, but let's try it again. Now I got a success. If I try this to this, well, let me try it again. So there's a reason the first one will always fail. Even if you do it from the CLI, let me do it from the CLI. Let me ping this guy from the CLI. I also expect the first packet to fail, but there's a reason the first packet is failing. This is dot 49. So let me ping from here to dot 40 now. CLI. Ping 10.10.10.49. So the first packet will fail, but I expect the second one to succeed. Yep. And that will happen for, this guy is dot 50. So if I ping dot 50, all right, so we're getting a response back. Now the computers can ping each other without a problem. I can ping from here to here. The first one will fail, but if I ping again, it should succeed. Yep, it succeeded. If I ping from here, expect a failure, ping again, it should succeed.
Why is it failing?
App. So you know what is app?
What did you say?
Do you know what is app?
Okay, I think yes.
App is the cause why the first one fails. But we discuss app some other day. I don't want to start talking about app right now. So go ahead and ask your questions, please. Now the entire topology is communicating, talking to each other without a problem. Ask your question. I know it's a lot. Trust me.
All right. So
Go
this
ahead.
this kind of like the whole building, right? That's the network for the whole building. Like, is it, I just
For maybe possibly for a one building, yeah, you can have this kind
yeah
of
for the
topology
building.
in a
This is
building.
not like
Yes.
external thing. All right. Okay. And then what was the second question I wanted to ask? All right, but the second question that I wanted to ask, saying this way, can we enable DHCP in this one? Like since we did a static one, if we were to do DHCP, it can they assign it? It can you do you think it will work automatically?
If you have a DHCP server configured, all you need to do is to come to the computer and change it to DHCP option, and it will get an IP. But you need to have DHCP set up somewhere.
Like how do you like what do you mean by that? Like
DHCP is your next topic, so let's not run.
all right, cool.
Yeah,
Done.
but possibly Ma will be doing DHCP next week. Or if she's not available, I'll take it.
Okay.
Hello?
Go ahead.
Hey, I just want to ask a question.
Mm-hmm.
The last time I actually tried packet tracer, like the first person that taught me, though he didn't teach me much, he used for the default gateway, he used the let's assume 192.168.10.0. Like 0 is always at the extreme edge of all the or the default gateway. I don't know if you understand what I'm saying, man.
I want to know I'm trying to understand what you mean.
Okay, for instance, look at this height now. We have 10.10.10.0. We
Mm-hmm.
have 10 dot under the logistics, we have 10.10.10.32. So it is that it is all these figures that he used as the default gateway.
These network IDs.
Yes. I don't
You
know if
think
it's
about it.
something wrong.
The only way you can use this is if that is not the network ID. Maybe that is
Okay.
an IP in that network, not the network ID. You can never use the network ID. We can try it. You see, it's not going to work.
Okay.
It's not
Okay.
going to work. If I want to, even though that interface is not connected, this last interface, if I try to assign it, the next network that we had here was let me make it. This is 10.10.10.64/28, right? That will be the next IP in this our subnet.
Yes.
So if I assign, you would say that this first IP is assigned to to the router interface. Let's try that out and see. On this router, that interface is, this exited so fast. If I show IP interface brief, we're gonna try to assign it to this interface, even though it's not up, but the behavior you get here is the behavior you get on any interface. So I do go into config mode, config T, enter into interface G4/0, and then try to assign IP at 10.10.10.64. Do 255.255.255.240. Let me know if my knowledge of network is failing me. That will never work. Because this is a network ID. You cannot assign a network ID to anything. It won't take it, even to your PC. So the only reason that will work is if that is not the network ID. Maybe that IP is an IP in that network. Because you see some people write, if I want to write the IP address on this interface right here, I can write it as, maybe if somebody asks me what is my router IP address, I'm going to give that person 10.10.10.35/28. I'll give you the IP like this. It does not mean that this is the network ID. This is a single IP in this network, and I can assign it to an interface. Does that answer your question?
Yes, ma'am. Yes, ma'am.
All right. Further questions?
Yeah, can you please drop those? I can do it. Yeah, I'm gonna say if we can have those note that you had on your notepad, that would be helpful for
These
us. Yeah,
commands?
yeah, these commands.
I'll put it on the, let me see if I can put it
Discord.
on the chat now.
Yeah, so
There it is. Questions, 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 questions. I know it's a lot to take in. It's a lot, but you can do this. This is just the simplest network you can create. The simplest network. Let me show you one topology. Let me stop sharing my screen. I'll find the topology, I'll share it with you. So you know this is one of the simplest network you can create. No, I don't want these guys to see this. Let me find it. Oh no, don't tell me it's not on this computer. Okay, I think it should be some.
So please, I'd like to ask all this topology and stuff. Can you do it wirelessly?
Oh yeah, you can introduce a Wi-Fi to those switches and then have the computers connect via Wi-Fi, via access point.
Okay, thank you.
It's a project I give my last student that I'm looking for. This is project number 4. Let me see if that will open. that project was created with 8.2. I don't know if it will open in this 9.0. That's another problem I have with Cisco packet tracer. Okay, it opened. It opened. So like I said, this is the smallest topology, the basic topology you can create. This was one of the projects that I gave students one time. Let me see if you guys can still see my screen. Can you see my screen?
Who did this?
Can you see my screen?
Damn, you did this?
Not you. You people did not do this. Of course, you didn't do this. This project had routing protocol. It had DHCP. It had DNS. It had VPN. It had a radio server. It had a post security in it. It had VLANs. It had the VTP. It had a lot configured there. This is a full production environment topology. A lot was set up here. He had VLANs, he had VTP, he had quite a lot. This was
Ma, you did it.
One of my students did this.
Ah.
This is a project for my student. It was one of my final projects for my student. This has IPsec VPN in it.
Sorry, ma. Do you mean online student or school, physical
Online
student?
students. Online students. He had NAT in it. He had ACL in it. Name it. He had quite a lot of things that we covered during our trainings.
I better bring that crypto barcode.
So that's what I'm telling you. This is one of the basic topology you could do. And if you don't understand the basics, it will be difficult for you to actually build on top of the basics to develop, because this is the basic. You need to know how to configure those interfaces. You need to know how to bring them up, and then you build on them as time goes on. And of course, this project had subnetting in it, because they had to subnet for each of the VLANs.
Ma, how long does it take the person to do this?
Normally, my projects take 2 weeks. If I give you a project or not exercise, assignment is 1 week, project is 2 to 3 weeks.
So if you now get to production, I mean, the reality, the field itself, the company, is it this template to send to them that they would build their infrastructure on?
It depends on what the company was, because if you're designing for a production environment, you need to do the simulation, do the configurations. So if you're presenting it to the C-level, you need to have what it will look like, the logical topology, what it's going to look like. And then you know how many devices you need, how many routers, how your cabling will be, and then you can deploy in a production environment. But you need to set up the configuration in a simulator to make sure that it will run without a problem or with little or no downtime.
Please, as we were doing the configuration for the interface, I use the UI to do the router interface. Is it accepted? Is it allowed to do that?
It's acceptable. You can do it, but that is the only thing you can do on the UI of Packet Tracer. only configure the interfaces. So usually I just go ahead and use my CLI. It's faster. It's faster to do over there.
Okay, thank you.
So yeah,
does
I would like to know if they give you a project work to do as workplace, do you design these on packages?
You mean me personally?
I mean, I don't know. It could be you, or what do you think? You have people, other friends in the field.
Yeah,
What
if
they
you have a project in an enterprise environment, if you have a project, they give you a deployment to do. You cannot just jump into deployment. You need to set up your staging environment. You need to have a simulator. Because if you don't have a simulator, how are you going to know where to connect what and what to connect to? So you need to build your topology out first. Then you can be looking at your topology while you're doing the real life setup.
okay?
Imagine, because these things will come as a write-up. They will come as a write-up. This entire project came as a write-up. Nothing, no design was given. It's a write-up. Then they converted everything into a topology and configuration. So you're going to translate the words into technical terms, design it, and configure it.
Okay.
What they got to work on this project was just a text file, is all they got, a text file. But the text file had what is the requirement is, what features are needed, and how we want the network to be secured. So they just translated everything into topology and build it up.
Right. Okay.
Please ask your question.
Does Cisco has automations for this?
Why are you always looking for shortcuts?
I'm not looking for shortcuts.
Steven, why are you
Life
looking
is
for shortcuts?
life is getting easier now.
There is no shortcut here. You will learn how to do it, even if there is a shortcut, right? That's what I tell people about using AI. For you to even use AI effectively, you need to know what is expected and what is unexpected, because AIs, they're going to do what we call hallucination. And when they hallucinate, your knowledge of the domain is what will let you understand when the AI hallucinates. Otherwise, you are doomed. So even if there is a way of automating this, you still need to know how to check if whatever was generated is right. And the only way to do that is that you understand what the expectation is, so that you don't just run with whatever it is that the automation system gives to you. Does that make sense?
Yes, ma'am. Yes, ma'am.
Solomon!
Mom, I'm here.
How is
I'm
it
here.
going?
Thinking backward.
It's going backward. It cannot go backward.
Again
Simon,
backward.
are you still trying to marinate it, since we are dealing with the chicken and turkey here?
I'm just looking at it. Everything sounds so strange and new. So I'm just looking at it.
It's expected,
Yeah.
trust me. It is expected
Just
to
looking at
be
it.
strange. It's expected to be weird, especially if it is your first time. There are people I'm not calling out here because I already know that they are past this level. I cannot come and be asking NS or something what I'm doing right now, because I know they are bored. They are bored with whatever it is that I'm doing right now. So it is just you start and then you build on it.
Man, we are not bored though, we are refreshing.
Mm. All right, guys, ask your question. So you're going to get a small exercise. The exercise is not to know how far you've learned, it's for you to be able to work on it on your own, and then build your topology, do your subnetting, and then learn from it. Please, 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 if you do that exercise by yourself, in line with the recording of this class, I don't think you will come back next week the same person that is going backwards, Solomon. T1, I'm not sure that you will continue to marinate, because this is a marination. I'm still trying to figure it out while we're marinating here. So please, if I put out the exercise, try as much as you can to do it. Try as much as you can to do it. The exercise will come with subnetting. It will come with building a small topology for yourself. But try as much as you can to work on it before the next class. Of course, you're going to submit this one. Chidima will look at it, but you're going to submit it. If you don't submit it, you won't get access to the class over the weekend. So ask your questions, please. Question, question, question. I don't want to introduce more things here. So let's end here for today. That's a long brief. Question, question, question. If no question, I'm going to stop recording before I continue talking.